Yeah. In this particular figure is all of this, all of this, all of this, and all of this. Now, looking at that, what two figures am I really working with?
Square and circle.
Square and a circle. There are some triangles involved, but they're not going to be as useful as just trying to see that whole square there in the middle. So what I'm going to do, say, well, first let's get the stuff I know I can get. The area of the whole circle is pi r squared, right? So that's going to be pi times, what's the radius in this case? 3. Ladies? So pi times 9, which is an answer. It should be on the order of 28 or so. 3.14 times 9. Yeah, 28.26. Now, if you're in a hurry because you're working on perhaps a standardized test or something, you could just round that, and you'll probably get within an answer or two. It's actually 28.6, not 9. A little vertical dyslexia there. Now I have to figure out how to remove that part in the middle because I've got that box to knock out. So let's go ahead and grab...
It could be 28.3 because it gives you 28.26.
Yeah, you can call it 20.3. We're not trying to get a guy on the moon. We got some leeway. So in the middle is a square with a diagonal of 6. So how do I get the area of that thing? Can I figure out how long these are? I mean, when we did special right triangles, that's a 45, those are two 45, 45, 90 triangles, right?
Divide 6 by the square root of 2.
So I could just take 6 and divide it by the square root of 2. And if I'm not comfortable with that, I could also do this and solve that, and you're going to end up at the exact same place, which is that x is 6 divided by the square root of 2. So let's see what that works out to be. 6 divided by 2, take them square root, equals...
Why are they all square?
4.24. Here's a right triangle.
Oh, because there's two right triangles? Or...
Yeah, I'm just going to look at this right triangle.
Alright.
So the Pythagorean theorem says a squared plus b squared equals c squared.
Oh, yeah.
Or I could use that special right triangle property we've talked about that I remember and say, well, since I'm going from the hypotenuse to a leg, I divide by the square root of 2. So now that I've got that number, the area of that triangle is 4.24 squared, which is a perfect 18. So am I adding or subtracting these areas? Subtracting, because I cut out the middle. This square in the center of my coin is a void. So I'm not worried about trying to find anything here. I'm going to cut that out. So I take the area of the overall disk, 28.26, minus the 18 that I cut out of the middle. Final answer, 10.26 square inches.
But how would the x squared plus x squared equals 6 squared work if you only have one side?
It's a square, isn't it? So these are both, so x's are the same. When you solve this, you're going to get 2x squared equals 36. X squared is equal to 18, or x is equal to... Which is also kind of neat. If you do it that way, you get x squared is equal to 18. And you go, oh, but I'm going to be squaring it. So there's where the 18 comes in. What else can I say about this guy?
Wait, aren't we not
No,
done?
that's it. We're done. That's the area of the shaded portion. So the shaded portion is just this region, just these 4 regions here. So when I found the area of the circle, that was the whole thing. Then I subtracted off the square that was in the middle, and that leaves me my 10.26 square inches. The other thing to bear in mind with these is make sure your answers are reasonable. You're not going to have a negative area. So if you get that, something's wrong in either your planning or your execution.